Good day, dear teachers and students. Today we would like to present our topic electrophilic substitution reaction in the benzene ring nitration. We are third year students of the Chemistry Biology Educational Program Group HBK 221. Utekin Jambibi, Kalbay Mirvet. Let's start.
The plants. Electrophilic aromatic substitution reaction, activating deactivating groups, formation of ortho, meta, and para-substitutive benzene derivatives, electrophilic aromatic substitution mechanism, nitration of benzene.
So, the first thing we need to understand is what electrophilic aromatic substitution reactions are. Organic reactions wherein an electrophile realizes an atom which is attached to an aromatic ring. Commonly, these reactions involve the replacement of a hydrogen atom belonging to benzene ring with an electrophile. In electrophilic aromatic substitution, a CH bond is broken and a new Ca bond, a binding electrophilic atom such as chlorine, bromine is formed. Each of these reactions requires an acid catalyst to activate it so that the reactively unreactive aromatic ring will attack it.
The next, some electrophilic aromatic substitution reaction, and sulfonation, alkylation, acylation, halogenation, nitration.
Now, let's talk about how different groups affect the rate of electrophilic aromatic substitution reaction. The rate of electrophilic aromatic substitution reactions is significantly influenced by substituent groups attached to the aromatic ring. The more electron reach the aromatic ring, the faster the reaction process. Groups that can donate electron density to the accelerated electrophilic aromatic substitution reaction. Now, let's go more detail about activating and deactivating groups. Activating groups increase the rate of electrophilic aromatic substitution reaction relative to hydrogen. Examples: hydroxy, alkoxy, amine, amide, and alkyl groups. Next, deactivating groups. Deactivating groups decrease the rate of electrophilic aromatic substitution reaction relative to hydrogen. Examples: halogens, carbonyls, cyano, nitro, and haloalkyl groups.
Next, we will look at how different substituents influence the orientation of electrophilic aromatic substitution. The two main patterns by which various substituents direct electrophilic aromatic substitution. In one pattern, substituent directs the reaction to the ortho or para product. Ortho product the 1,2 position of para product 1,4 position. In the second pattern of different family of substituents direct the reaction to give primarily the meta product of the 1,3 position. The next, examples of ortho, para, meta directs. Ortho para directs of hydroxyl, alkoxyl, amino, alkyl, and halogen groups. The next of meta directs of cyano, carbonyl, and nitro groups.
Next, electrophilic aromatic substitution mechanism. Electrophilic substitution is mechanism that is observed at aromatic rings like benzene, phenol, phenylamine, and electrophile is defined as in electron pair. Accept through this mean it will have an atom with this a full positive or partial positive charge that is able to attract and accept an incoming pair of electrons. Let us take a look of the electrophilic substitution mechanism for the reaction between benzene and positively charged electrophile. As the electrophile approaches the benzene ring, it attracts the electrons in the dealkalized pi system. A pair of these electrons are then drawn out to form a bond with the electrophile. This leaves is with a benzene ring where the dealkalized pi system has lost electron density, with we can represent with a broken ring with a positive charge in the. We also have a new bond form one of the carbons to the electrolyte. But we need to remember that this carbon was already bonded to the hydrogen. The benzene ring wants to reform with its dealkalized pi system, as this would be a lot more stable. It does this by losing the hydrogen that's attached to this bicarbon. The electrons from this bond go back. Benzene with the electrolyte attached. The overall effect of the reaction is a substitution, as a hydrogen swapped for an electrolyte. Let's take a look at some examples of this mechanism in action.
Mechanism of nitration benzene. Benzene reacts with mixture of concentrated nitric acid and concentrated sulfuric acid to form nitrobenzene and water. In this reaction, concentrated nitric acid and concentrated sulfuric acid with sulfuric acid acts as stronger acid and protonated nitric acid. This forms the reactive electrophile neutronium ion. This ion is the species that actually reacts with benzene in the nitration process. In stage number 1, in the mechanism, the electrophile neutronium ion is attracted to the high electron density of the p system bonding in benzene. A pair of electrons from the benzene ring is donated to the nitrogen atom in neutronium ion and forms a new covalent bond. The electrophile attacks the p electrons of the benzene ring, forming a carbocation known as the aryonium ion, which is stabilized by resonance. This carbocation has 3 resonance counterparts. Electrophile attack is slow and requires high energy due to the loss of aromaticity. This carbocation is attached by base lotus proton, and the electrons are used to reform the p bond, restoring aromaticity. The step is fast and exergonic. It is important to note that the proton is lost where the electrophile attacks the ring. As a result, nitrobenzene and water molecule are formed. Conclusion. Electrophile substitution reaction are K-class of reaction characteristic of the benzene ring. In this process, a hydrogen atom on the benzene ring is replaced by electrophile, while the aromatic structure is preserved. Nitration are typical examples of electrophile substitution. The reaction occurs in a mixture of nitric acid and sulfuric acid, where the neutronium ion acts as the electrophile, replacing a hydrogen atom on the benzene ring. As a result, nitrobenzene is formed. This reaction is one of the fundamental processes in organic chemistry and plays an important role in the synthesis of various compounds, especially in intermediates in chemical production.
Thank you for attention.